Welcome back to Boiler Wild. My name is Eric Johnson. On this podcast, I talk about boiler industry topics as well as personal development. Wild, the name actually stands for something. Work hard, invest in yourself, lead others, and develop yourself into a person of excellence. If you are listening to this podcast, I hope that you are on a journey to achieve whatever life goals and dreams you have and to make the world a better place around you. But in order to do that, you have to be the person that becomes better. You cannot rely on others. It is not anybody else's fault but yours that you are not learning or improving or working down on your fitness journey or whatever it is, and working hard, because sometimes the boiler industry just requires hard work and there's no ways around it. And if you get used to hard work, that becomes the standard and it becomes normal, and you will do a lot better than the people who actively run away from hard work. So I encourage you to always do stuff like that and work hard. I am trying to work hard, trying to walk 10,000 steps every day, which is a challenge sometimes because I am not moving around a lot on some days. Just sitting in front of a computer, it can be like the whole day just goes right past me. I sit down and all of a sudden I think I'm hungry and it's 5:00 and I'm like, oh man, I need to move. So that is the whole goal of 10,000 steps a day, to walk and have a little bit improvement, maybe slim down a little bit for summer. Also, consistently going to the gym. That is something else I am doing. I would encourage you, if you have a fitness journey that you want to partake on, the best time to start is now. There will never be a better time, and your future self will thank you. Today, I want to talk about something very, very important for a heating hot water system. Is going to be the point of no pressure change. This was made famous by the one and only Dan Holohan with his number one book, I would say, that is definitely recommended. I'm pretty sure the people online recommending the book have never even read the book because they think it says something that it doesn't really say, but maybe that's just a conspiracy theory that I will keep to myself. But if you go on any forum online and people are saying, what kind of boiler books should I read? Almost always the number one response is Pumping Away by Dan Holohan. And while it is a great book, and while it does have some great information in it, it's not really like a beginner book of, oh, this is the number one place you should start when starting with boilers. And if you're working only with hot water boilers, yeah, that's a great start. But if you're working with steam boilers, Pumping Away isn't going to really do much for you. And I think a lot of people just repeat it because it is a popular book to repeat. But it is a great book. I am not denying that. And Dan also has lots of other great books. So if you haven't read his books and you don't have his books, go online, go on heatinghelp.com and buy all of his books and read them. You will be a better person. So Pumping Away is this thing that came around, I believe, in the 60s, if I have my history correct, from Gil Carlson. And Dan Holohan learned a lot from Gil Carlson. And essentially, there's a point in a hydronic system where it is the point of no pressure change. And that is the whole concept of pumping away. And a lot of people think it's pumping away from the boiler, and it's indirectly that. So on older hot water systems And you got to think small, light commercial stuff. All Dan Hollihan stuff is all residential, light commercial boiler stuff, but it definitely applies to larger stuff. Hydronics is hydronics, but the expansion tank was just a normal compression tank. So no diaphragm, no bladder, just a tank. And most always, those tanks were always installed by connecting them somehow to the top of the boiler. So if you are pumping away from the expansion tank, and I'll get into that, you have to pump away from the boiler and not pump into the boiler. So you would put the pump on the outlet side or the supply side of the boiler instead of on the return side. So a lot of people think that pumping away means, oh, I need to pump away from my boiler, but it is pumping away from the point of no pressure change. And that is what is important. Pumping away from the boiler can be important depending on how the boiler is set up. Some boiler manufacturers will just have the pump pre-installed on the return side and be pumping towards the boiler, but it's the pumping away. You have to make sure that you are pumping away from your expansion tank, which is the point of no pressure change. If you want to pump away from your boiler, you can do that as well, but that is not the core concept of pumping away. But if your expansion tank is connected to your boiler at the top of it, like it is on like a little cast iron boiler, then you will need to put your pump on the supply side of the boiler and pump away from the boiler. If you pump into the boiler, you will also have a little, if you're right on the edge of the pressure or the relief valve, you may have the valve lift a little bit if you are pumping towards that. So that does also pose an issue, but pumping into the boiler isn't wrong per se. There's nothing wrong with that. The whole pumping away concept, once again, is the point of no pressure change, which is all about the location of the expansion tank versus the pump. So what is the point of no pressure change? You have a hydronic system, and we're going to say the fill pressure is going to be 12 psi. And the point of no pressure change means that when actually, let's back up. So a circulator doesn't actually create pressure. It creates a differential of pressure. And the pressure differential is what causes water to flow. If you fill up a pipe and you fill up your whole house, you fill up your hydronic system with water, and then you sit there and you just expect the water to move by itself, you're going to be sorely disappointed because all the pipes are full of water and now there's no pressure differential, so the water's not going to move. So we have to make the water move. So that is why we add a circulator to the piping. And yes, I know that you can also make water move by just heating it, but we typically don't do that anymore. That is old school hydronics of just gravity systems, but most systems are not gravity systems. So you add a circulator, especially in the commercial industrial, you'll never find a gravity system. You will always have circulators. So the circulator, it makes the differential pressure. So you will have a positive pressure, a more positive pressure on the outlet, and a less pressure on the inlet of the circulator. And that causes the water to move. And I say less because it's not always positive depending on how you set up your system, but it should always be positive on the inlet. If you don't have positive, you may not be pumping away, or you have not enough water or pressure in your system. So if everything is equal, so we're not heating the water and everything, the circulator, it has say it's going to make 15 psi on one side and 7 psi on the suction side. If it is pumping towards the point of no pressure change, it cannot make that point at the expansion tank 15 psi. And that is because it cannot push water into the expansion tank, not even a drop. The entire hydronic system is full of water. And if you push water into the expansion tank, it would create a vacuum or a void in the piping because you only have a fixed amount of water. And that fixed amount of water, you can't just magically move water into the expansion tank and fill the expansion tank more to increase the pressure without adding more water to the system. And that is why it is the point of no pressure change. So instead of the pump adding 15 psi or going to 15 psi, it doesn't add 15 psi, but on the outlet, it will measure like 15 psi. Instead of the pump measuring 15 psi in the outlet, it will actually only measure 12 psi on the outlet, but then it will make it up on the suction side of it, and it will read whatever the suction will read, and it'll be like 3 psi. And that will be the differential between the positive or the outlet of the pump and the inlet of the pump. So where you get into trouble is when you have a vacuum on your pump inlet. So if the pressure of the system is not enough and the differential pressure across the pump, if you are pumping towards your expansion tank, you can get a vacuum. So when the pump starts, it cannot create more pressure than what the expansion tank is. So it's going to just be 12 psi, and then it may create a vacuum on the inlet of the pump, which causes cavitation, but it will also bring air or more makeup water into the system depending on where your makeup fill is. Because if your makeup fill is set to 12 psi, and then all of a sudden the pressure drops right when the circulator comes on, this will only happen once, but the circulator will come on, drop the pressure on the suction side of the pump, and now the makeup will try to make that suction side 12 psi, and it will feed water, but that water will keep feeding, and then it will then increase the overall pressure of the system. So now when your pressure was supposed to be 12 psi, it may be 15 or 18 or 20 psi, whatever it is, and you don't want that. So the pressure of the system after you turn on your circulator, and then you'll bleed out the pressure, you bleed out the water, reset the expansion tank, and then it'll just happen again. The other part of it is the vacuum on the pump inlet. So if it creates a vacuum, it is going to want to pull air into the system, and a lot of systems have automatic air bleeders, and believe it or not, you can pull air into the system. They are not one-way check valves where air only goes out. You can also pull air in. So if you have a pump that is going into vacuum on the suction side of it, it will pull air into the system. And that will screw up your system because air in a hot water system causes all kinds of issues. So if we pump away from the point of no pressure change, which means the suction side of the circulator is on the same side of the system as the point of no pressure change, aka the expansion tank, now the positive side or the outlet side of the circulator can increase the pressure and create the pressure differential it needs to in order to move water without dropping the inlet side of the pump below zero or very low and close to zero. So if you had a 12 psi system, you could have 15 psi on the outlet and say 7 psi on the inlet, and now you're not creating vacuum, you're not having cavitation, and the pump works excellent. You're not drawing air into the system, and your makeup fill valve is not adding more water to the system than it needs to. That is pumping away. It is a very simple concept, but when you walk into a mechanical room, it can get a little confusing because you are typically taught piping concepts on a 2D plane, maybe a little 3D plane, but it's always going to be like on a computer screen or on a piece of paper. And then seeing it in person can be a little bit different, but you just have to remember that your circulator needs to be on the downstream side of your expansion tank. So typically what this looks like is going to be your boiler is going to be installed, and then on the outlet of your boiler, you are going to have whatever, but somewhere on the outlet of the boiler piping, and this can be like in the first 10 feet. Like this is not like right at the outlet of the boiler, but you have the outlet of the boiler piping, and then you are going to have your expansion tank connection to the system. And then you're going to go down a little bit and say, like, on a commercial system, this could be 5 feet, 10 feet, whatever. And then you will have your circulator. And the spacing between them doesn't really matter, but that's the order that is correct. If you have your boiler and then you have a circulator and then you just randomly connect your expansion tank after that circulator, you are now pumping into the point of no pressure change, and you are going to have all those issues that I previously mentioned. So boiler, expansion tank connection, and circulator. That is how you want your connections on your hot water system to be connected, in that order. If you do find a circulator pumping into the point of no pressure change, it is easier to move the expansion tank connection. Typically you can, if it is just a normal expansion tank, like a bladder tank or a diaphragm tank, you can just move the connection to a different spot of the system. You just want to make sure that you are moving it to the right spot of the system. You have to pay attention to where your expansion tank connection is, and that you are not isolating the expansion tank from the proper parts of the system. I won't get into all that, but it makes a difference where your expansion tank goes when you have like primary variable piping versus primary secondary piping. You can't just randomly connect your expansion tank anywhere in the system. You will always want it basically right on the somewhere between the boiler and the suction side of the circulator. If you were to put it in the middle of the system and, halfway down the piping, and if you draw it out in a loop and it's in the middle, now the pump is only going to still be pumping. It's going to be not directly pumping into the point of no pressure change, but it's going to be split in half. So now the other half of that pressure is going to be made up on the suction side to create that differential. So you want all the differential that you can of the pressure to be created on the outlet side, and then have the suction side be the point of no pressure change, so that remains always in a positive pressure. Not super hard of a concept. If you don't understand the concept, I would read the book. I would also just go watch the YouTube video as well. But at a core, at the basic, even if you don't understand it, try to visualize it. It is important to understand, but if you remember that you have your boiler, you have your expansion tank connection, and then you have your circulator, and that is your circulator is going to be pumping away from the expansion tank, which is called the point of no pressure change of the system, because the circulator cannot push water into the expansion tank with everything else being equal in the system. So that's all I have for you today. That is the point of no pressure change. That is what it is. Short and sweet. I hope you learned something. If not, I have failed you. I am sorry, but I will do better. Let me know. If you haven't already, please rate this podcast 5 stars. That really helps me and helps others discover this podcast. Remember, when you next do a site walk, look for your expansion tank connection and look where your boiler is and look where your circulators are. Your expansion tank should always be connected on the suction side of the circulators in between the boiler. If you are doing it right, you can also have the expansion tank be on the suction side of the pump, but the pump be on the return side of the boiler. That is fine as well. That is sometimes preferred by some manufacturers, but most of the time in commercial industrial, where you have a separate circulator that is not part of the boiler, you are going to be able to place the circulator wherever you want, and you're going to be putting it on the supply side of the boiler. And on the suction side of that circulator, you're going to want to make your expansion tank connection. And also, that is typically where people will also put the connection for the fill, the PRV for the pressure reducing valve, the makeup water for the system at the point of no pressure change. That is typically the spot where you want to put it as well, because it is the most stable spot of the system. Also very easy to make up some fittings and make up standards of how you connect the makeup water to the system versus where the expansion tank is. And if you haven't already, go back and listen to episode 68. I talked about expansion tanks, but they have to properly be set up for the system. If you have not enough air in your diaphragm or bladder tank, or even your compression tank, but you actually add an air charge from like an air compressor to your bladder tank or your diaphragm tank, if that air charge is not correct, you will have issues, most likely popping your relief valve on your boiler, which is always no good. But keep in mind, point of no pressure change, pumping away. Go read the book if you haven't already. Go watch Dan Hallahan on YouTube, his classic hydronics 3-hour seminar. It is a good watch. I hope you learned something and stay wild.